complex matrix. So definition, okay, let A be any square matrix we say that matrix A is complex matrix if all its entries are complex number. So that is entries of matrix A are of the form A plus IB, where A comma B are real numbers. So here for example, so matrix A, so I will take here 2 plus I, 7 minus I, 6 plus 5I, and here 1 plus I, 0, 8I, 5 plus 2I, here 2I, 1 minus 5I. Okay, now here the conjugate of A plus IB is A minus IB. So how will you get means replacing I by minus I. Now conjugate matrix. Here the entries of A conjugate are obtained by replacing entries of matrix A by their conjugate, and it is denoted by A conjugate, like this symbol they will use. Okay, so here example, so I'll take A matrix. So what do you get here? A matrix. I'll take same matrix here, complex matrix here, minus I, 6 plus 5I, here 1 plus I, 0, here 8I, and here what do you get? 5 plus 2I, here 2I, 1 minus 5I. Now you have to take conjugate for this one. So you have to take conjugate for this one. So what do you get here? Conjugate of matrix. So what do you get here? So I is what do you get here? I is replaced to minus I, so we'll get conjugate matrix. So what do you get here now? This becomes 2 minus I, 7 plus I, and here 6 minus 5I, and here 1 minus I, 0, and here 8I, and here 5 minus 2I, so minus 2I, and here 1 plus 5I. So this is the conjugate matrix. Next here, conjugate transpose matrix. Conjugate transpose matrix. So here they will give here complex matrix. You have to find out the conjugate matrix, and then you will get an conjugate. You have to take transpose for that one. So then you will get an conjugate transpose matrix. So now here definition. So definition, let for any matrix, obtained by taking the transpose of a conjugate matrix. Conjugate matrix is called conjugate transpose matrix. And it is denoted by A star, and is denoted by A star. So example, so I'll take complex matrix, so 1 minus I, and here 4 plus 3I, and 2 minus 9I, and here 4I, 5 plus 3I, 8I, 2 plus 3I, 7 minus I, and here 8 plus I. So now over here, now I have to find out conjugate matrix. So conjugate matrix means here conjugate matrix I is replaced to minus I, so I is replaced to minus I. So what do you get here? 1 plus I, 4 minus 3I, 2 plus 9I, and here minus 4I, 5 minus 3I, minus 8I, 2 minus 3I, 7 plus I, and 8 minus I. Now for this one you have to take it transpose conjugate matrix. So transpose conjugate matrix is what you get here, row interchange to column. So 1 plus I, and here 4 minus 3I, and here 2 plus 9I, and here minus 4I, and 5 minus 3I, and here minus 8I, and here next 2 minus 3I, 7 plus I, and here 8 minus I. So this is transpose conjugate matrix or conjugate transpose matrix. Okay, you have to remember these things you'll use in the problems. Next here, Hermitian matrix. Hermitian matrix or self adjoint matrix. Hermitian matrix or self adjoint matrix. So definition. Before that definition, so how will you get it is Hermitian matrix means here, so 1 minus 5 3, here I 1 plus I 2 minus 2 plus 3I, and here 2 minus 3I, and here minus I, and here 1 minus I. So here in diagonal elements you will get real numbers, so you will not get a complex number in diagonal, so that is called Hermitian matrix. So remember that one. So now I will go for the definition. So a Hermitian matrix is a square matrix which is equal to its own conjugate transpose matrix, and it is denoted by A star, and is denoted by A star. Then the Hermitian property can be written as A equals A transpose. A equals conjugate transpose matrix. So remember, it is like symmetric matrix. ಮಧ್ಯದಲ್ಲಿ ರಿಯಲ್ಸ್ ನಂಬರ್ಸ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಟೈಪ್ ಇರುತ್ತೆ. ಓಕೆ, now here example for this one. So I will take same matrix here, above matrix. So what I get here, 1 I 1 plus I, here minus I minus 5, and here 2 minus I 1 minus I 2 minus 3I 3. ಈ ಕಂಡೀಷನ್ ಏನಂದರೆ A equals A transpose, both are ಸೇಮ್ ಇರಬೇಕು, ಕಾಂಜುಗೇಟ್ ಟ್ರಾನ್ಸ್ಪೋಸು ಮತ್ತು ಗಿವನ್ ಮ್ಯಾಟ್ರಿಕ್ಸು. So now first I will find out conjugate matrix. So conjugate matrix means what I get, I is replaced to minus I. So 1 minus I 1 minus I, and here what I get, plus I and minus 5 2 plus I 1 plus I, here will get 2 plus, sorry this is I only, 2 plus I, and you'll get 3. Sorry, it is 2 plus I, and this becomes minus I. Okay, Now you have to take A star. A star means transpose conjugate. So what you get now, interchange row into column. So 1 minus I, 1 minus I. So look at here, you get same thing. Second row, right into column. I minus 5, 2 plus I. Sorry. Yeah. Same ಬಂದಿದೆ. So next here, third row, you have to interchange this one. 1 plus I, 2 minus I, 3. So e row, e column same ಬಂದಿದೆಯಾ? So therefore A equals A transpose, conjugate transpose. So we have to remember, you will get in problems. Next here, not. So the diagonal entries of an Hermitian matrix are real numbers. So here ಇಲ್ಲಿ real numbers ಇರಬೇಕು. Okay, so next here this implies here Aij equals here conjugate of Ji, or this implies Aii equals conjugate of Ai. So next here skew Hermitian matrix. So how will you find out it is skew Hermitian matrix? Means here diagonal element should be 0. In all here what you get, you will get complex numbers. Okay, diagonal element should be 0. So that is called skew Hermitian matrix. So remember that one. So definition: a skew Hermitian matrix which equal to negative of its own conjugate transpose matrix. So that is a square matrix. Square matrix A is skew Hermitian matrix if A equals minus transpose conjugate matrix. So you have to remember this one. Okay, you'll use in the problems. Okay, so next here unitary matrix. Unitary matrix. A complex square matrix. Square matrix A is unitary if transpose conjugate matrix into A matrix equal to A into A conjugate transpose matrix equals, you'll get identity matrix, or A inverse equals A transpose conjugate matrix. If you get, then it is an unitary matrix where I denotes denotes an identity matrix. Identity matrix. And A star is the conjugate transpose of matrix A or given matrix. Okay, so you have to remember these things. So properties. Properties. First one, the sum of a square matrix and its conjugate transpose, that is A plus A transpose, is Hermitian matrix. Hermitian matrix. Second one, if given matrix or A is any Hermitian matrix, then I into A is skew Hermitian. Matrix. So otherwise it is vice versa also. Remember that one. These properties are very important. They will ask in exams also next year. Third point, the eigenvalues of any Hermitian matrix are real, and those of a skew Hermitian matrix are purely imaginary. purely imaginary or 0. Rest of the eigenvalues of orthogonal and unitary matrix have absolute value 1. Absolute value is 1. Fourth point, if A is any square matrix if A plus A conjugate transpose A conjugate, and here A conjugate transpose into A, or A into A conjugate transpose, or Hermitian matrix. Hermitian matrix, and A minus A conjugate transpose matrix is skew Hermitian matrix. Skew Hermitian matrix. Fifth point, A transpose A inverse, and here scalar into here A matrix are all unitary matrix if A is unitary. Condition is that A is unitary ಆಗಿರಬೇಕು, ಆದಮೇಲೆ ಇವೆಲ್ಲ ಕಂಡೀಷನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗೋದು. ಸೊ ನೆಕ್ಸ್ಟ್ sixth one, a product of two unitary matrix is unitary. So seventh one, any square matrix can be expressed as P plus IQ, where P and Q are symmetric matrix. Remember this here. So these are very important. They will used in the problems. Here next point, the difference of a square matrix and its conjugate transpose conjugate transpose, that is A minus A transpose is skew Hermitian matrix. Skew Hermitian matrix. So next here, ninth one, an arbitrary square matrix C can be written as the sum of Hermitian matrix A and a skew Hermitian matrix B. So this implies that C is equal to A plus B, where A equals C here, C plus C transpose divided by 2, and here B equals C minus C transpose divided by 2. So you have to remember these formulas. So you will get in you will solve in problems.